Thank you. Alrighty. So yeah, thank you so much for joining me to talk about monitoring event pipelines. This has been something I've wanted to talk about for a long time, but never got around to forming a series of thoughts on the matter that I could share in a repeatable way. So yeah, actually, I'm going to talk about monitoring event pipelines, why you need one, and why you should stop trying to roll your own. So who am I first? My name is Sean Porter. Thank you for that nice introduction. I'm the creator of the Sensu open source project that started back in 2010. And I'll talk a bit about that in this talk. I'm the co-founder and CTO of Sensu Inc., the commercial entity that's behind that project that really does the majority of the core development work. And then online, my handle is PorterTech on Twitter or IRC, although I'm not lurking there that often anymore, or Slack. You can find me via that handle. So a little overview of what this talk is going to cover. I just want to talk about our shared reality as operators and developers, what we experience on the day-to-day and what we're going to experience. I'm going to share my experience in building Sensu for some background and some context about some of the topics I'm going to discuss. I'm going to explain what a monitoring pipeline is. I've actually been surprised over the last 2 days to hear this term actually thrown around by other speakers, which is good because it means I'm not just talking about a made-up subject or term or some hype. It's got some concrete weight behind it. I'm going to talk about some attributes of an effective pipeline. So, if you build one or use one, what is going to give you a higher rate of success in that effort. I'm going to do a number of demos, live demos. I got to pray to the demo gods that it all works out. And then the future of pipelines, kind of where I see the technology going, as well as like practices and general approaches. So our shared reality. I mean, for the last 10 years, it's just been this slow, steady growth in terms of complexity over time, right? Our applications have gotten more complex, and the infrastructure that drives them has also got as complex, if not more, right? We've gone from monoliths to microservices, from bare metal to VMs to containers to function-based computing. The amount of complexity that's involved in even like, a simple e-commerce app to buy shoes. Somehow it requires 100 servers and 300 microservices. The number of things is also increasing, right? We used to operate in a number of tens to hundreds, then thousands. Now we're talking tens of thousands of machines for even medium-sized organizations. And the technologies themselves, because the unit just keeps getting smaller, there's more of them, and again, it just leads to that complexity. We now have containers and functions, which are also extremely ephemeral, and some of them only run for a matter of milliseconds, and then they're gone. It's like, how do you observe something that is so fleeting, right? And really, like, we've been experiencing not just one paradigm shift, not two, probably about 3 in the last 10 years. The first being like cloud infrastructure. Then we have, containerization revamped, even that we've had containers for like 25 years. And now function-based computing based on these platforms. But what it's meant for monitoring is that we've needed to shift our models and how we approach these problems from things like host-based monitoring, where we're talking about individual machines, and more role-based monitoring, where things are responsible for certain actions and services. That's how we need to target and monitor and alert on. Polling models change because we're no longer able to talk about the individual server and pull them aggressively because they can be gone in an instant. We need to change how we do this to like publish, subscribe, or push APIs, right? We have to allow things to funnel into these pipelines. And then point-and-click tools, they don't really scale well. We're moving to infrastructure as code, whether that's something like a Chef or Puppet or Ansible, or even a YAML file for Kubernetes. That's infrastructure as code. That's kind of how we define what our infrastructure looks like and how we interact with it. So a common issue that we're all presented with as operators on a daily basis is like, here are a bunch of constraints, whether it be like budget requirements or hardware availability or people and time. And you've got to get data in format A into data format B, C, and D with very limited resources. So we have to get creative. And I think we're actually very creative people. We've spent our careers trying to work through these problems, and we always surprise ourselves in what we come up with, and sometimes we get proud. Sometimes we're horrified of the result, right? It's like, here's a bunch of bash I just wrote. Let's huck it over the fence. It works. And to make this a bit more of an issue, though, is that the amount of the data that you need to get from A to B is also increasing. You know, now medium-sized businesses are pushing petabytes of data. I mean, I believe this is most of us. Maybe, I don't know, maybe you don't smoke, but probably drink a little bit. It's kind of like, no worries, right? This is not new to most of us. I think we're aware of these problems, or we're aware that they're gonna start occurring for us in our organizations. And you think, I know a number of tools to solve a bunch of these problems. I can combine them in a way that I can create a full package solution. I think there's even a lot of consultants in the audience, and then I know you all package a number of tools together as solutions and then sell them and then support them. I think as individuals and teams, we do this internally in our own companies as well. We know we need to integrate things, but to integrate things, we have to build something, whether it be Bash or Perl or Ruby or Golang, and then we need to scale these things. And then, of course, you're presented with that question all the time, was like, do I build or buy, right? Now, you still have to integrate and build when you buy something, but maybe it gets you a little bit further. They sell you on that turnkey experience, but really you hesitate to build in most cases because you're aware of this problem that you need to maintain whatever it is that you build, right? I think this is the highest cost for building any sort of solution in the space to solve these problems. Yeah. That was SpaceX. Yeah. So if you're thinking about building something, just hold that thought. So I'll talk about my experience. I did this exact thing in 2010, 2011, where I had to scratch my own itch and solve my problems. I kind of want to just talk about, just briefly, my experience in that journey, and I'll get to monitoring pipelines right after. So I joined a company called Sony in 2010. I joined as an automation engineer. I was an operator. Working at a company that was on the bleeding edge, early adopters of a number of technologies, AWS, when there was only like 3 services, it's like EC2, S3, and one other one, and then EBS was actually a separate service for a brief moment. And there's an extreme high rate of change, right? The team was just growing rapidly, our technology stack kept changing. But right after I joined, I was woken up, you know, every time I was on call, we were getting 45 pages on average a night. So I was waking up very often. You know, I was not effective during the daytime because I wasn't sleeping. And really, it was like this cloud infrastructure, that early paradigm shift, causing all these problems for us. The existing tools didn't really work. We looked at buying things. There weren't really any products. We were too early for a lot of stuff, so we needed to solve it. So I came up with a project with some goals in 2011. To handle ephemeral compute, leverage existing familiar technologies, so be able to use my service checks, my Nagios plugins. I mean, there's over decades of people's time invested in that. And it needs to be easy to drive with config management, easy to scale horizontally, not up, but out. And then APIs. God, like in 2010, why was it that no monitoring tool had a bloody API? It was like, here's a Unix domain socket to cat, and then read some data from. So I ended up doing a weekend project that created an agent-based system with auto-discovery, so it would just self-register all your monitoring agents. It used a message bus for communication, so that gave me the ease of a horizontal scale. Simple key value data store was easy to operationalize. Central service check scheduler, JSON configuration, which is easy to drive with config management, and of course, REST APIs. So this is my first diagram that I made for a blog post back in 2011. It shows that, actually I can walk over here. This is the backend scheduler, and you can scale it out horizontally, and it basically publishes check requests, or like, I need these groups of machines to run this thing. It goes through here. You can see that I've got Elastic and web server here, so the correct check requests go onto those clients, they execute them, and then push results back for processing. We store it, and then we can serve it up via the API. And then we can do interesting things. We also have APIs and ingestion points into the client so you can push data in. This was quite interesting at the time. It was very different than many of the tools in 2010, 2011. And I actually people gave me a hard time for this diagram because it's not that great, but also they said there was too many arrows on it. And they're like, we need to use Nagios to monitor Sensu. Here's a cool anime GIF I made after for those people that gave me a hard time, just demonstrating kind of the flow of this really rudimentary, simple agent-based system. And really this allowed me to make the shifts, right, from host-based to role-based monitoring, from poll-based to pub-sub and push. We could really address a lot of those problems through that design. So it was designed for the cloud. How am I doing on time? Okay, cool. Proved to handle ephemeral compute, operated securely on public networks because I just leveraged an existing message bus, RabbitMQ. I had proper TLS, ACLs, and a few other things. So it worked great in public net or in secure networks, which I would argue is every network. And really just focusing on composability and extensibility, creating those reusable components and building blocks was really the only way that I could cut down on the cost of that maintenance, right? So by making it so extensible, but creating a framework for people in which to operate and extend, kind of keep things within the guidelines. You don't have so much sprawl and almost diversity in the code base. So what we ended up with were this cool framework and these components, or at the time I called primitives, where you could create your check objects, you create your filters, your mutators, and your handlers. And what you ended up with is an emitter of an event, being the check, filters to self-select and drop some, mutators to transform, and then handlers to take actions such as alerting or writing to a time series database, or triggering an Ansible run for auto-remediation. Named it Sensu. I spent 2 months in Japan. I was obsessed with Japanese culture. Plus, Sensu is actually the Japanese word for folding fan, which is made from bamboo and paper, and that's why our logo is actually a fan. So a little tidbit of info there. We open sourced it under MIT. And what's interesting is, let's see if conference Wi-Fi works. Hey, not bad. This is the Sensu plugins project that kind of just came out at the same time. And by focusing on composability and extensibility in these frameworks, it made it extremely easy for anyone to not only write check plugins, but also filter plugins, mutator plugins, and handler plugins. And we basically just got this momentum around this open source project around this. So it made me ask the questions like, why is this picking up steam and people are using it? What is it about composability and extensibility and, using this like message bus and pub sub model that's making sense to all these people? And for a while, we had this narrative where like, what is Sensu? And it was difficult. Like explaining what the heck Sensu was, I was like, it's an open source Nagios replacement. It was the easiest way I could explain it. But then people started to kind of gravitate to the monitoring framework, right? That composability framework, that extensibility framework. Monitoring router, it can route data to different data lakes or data bagels or wherever you want to put your stuff. Or the monitoring bus, right? It's something I just throw data onto and it ends up in the right place. And then eventually, we kind of landed on the monitoring pipeline. This was something, I think it was 2013, when we started to message this because, we have pipelines for other parts of our infrastructure, right? We have CI, like CI/CD pipelines, deployment pipelines, ways that we construct from an action or something emits data here, then there's a series of events, and then something happens over there. So it was a easy way to describe Sensu that was close to the things that people were already starting to build. Now what's interesting is in the last 2 months, observability seems to be like, everyone's just replacing the word monitoring with observability and it's the same thing. But I would say that, monitoring is the what and observability is the how or the deep introspection. But now this is starting to become a popular term. And I'm happy about that, finally. Like it's only been 6 years of me trying to explain the monitoring pipeline. Now they call it the observability pipeline, which is great for me because now everybody's starting to understand the idea and the concept. So what is a monitoring pipeline? My best way that I can summarize it is a unified data collection and processing for all types of monitoring events. Basically, one way to collect your monitoring data, and one way to process it and push it into something. This applies to your service checks, your metrics, your traces, your logs, your inventory, like I just found new servers, new network gear, that kind of thing. These are all monitoring events. There are two critical layers to a monitoring event pipeline: the data plane and control plane. The data plane, you can think of this as the body of the system. It's really, data input, data transportation, durability, routing, load balancing, failover. It's kind of it's just the vessel, right? It's just there to load the data on and get it somewhere. And this happens to be the layer that developers traditionally interact with. These are the APIs, right? Just give me a socket and a protocol. That's all I want as a developer, right? I don't want to know about your pipelines or whatever you're talking about. Just tell me where I got to put my data, and then show me where I got to look to see the dashboard. Then you've got the control plane, and I would argue that this is actually the most important part of a monitoring pipeline. It is the brain for the body. It is the central management unit, the orchestrator, the configuration, security, auth. This is composed everything from the APIs, the agent, the data processors, anything that really informs the pipeline, how it works or how it should work, and what to do with certain types of data. This is the layer operators interact with, right? Because we compose these pipelines for simply to be consumed by developers. And I would say that anyone can build this. This is easy, right? Let's grab Kafka, right? That's the best data plane that you can just grab. What I'd say is the difficult part and the harder part to maintain is the brain, is the control plane. Now, if you're confused on what data plane, control plane, all this jargon, there's a great YouTube video that was actually put out there by Microsoft and HashiCorp, and they explain the data plane and control plane kind of separation as it applies to service meshes. And what's interesting is like a service mesh isn't all that different from a monitoring event pipeline. It's a great simple explanation of A, what the heck is a service mesh, and B, what does the separation mean to operators. Now you've got those two layers, but you need the end result, right? Where is this data going? How are people going to consume it? How is it going to be useful? So you're going to have any sort of time series storage or event storage, log storage, alert mechanisms, chats, that kind of thing, or incident management like ServiceNow, or BigQuery and Bigtable at Google if you have a big data problem. So this is kind of like a common bidirectional monitoring pipeline or observability pipeline that's being thrown around in the last 6 months, where you have your VM, your container, your data collector that pushes into a pipeline. It's probably Kafka or Amazon Kinesis or something. Then you have one or more data routers which are processing that information. There's some sort of rules engine, and then it writes it to a data backend. And it's just surprising to me how many people set out to build this themselves. They're like, I know I can solve that problem, hold my beer, I got this, I'm gonna build this. And it can be scary because if you're looking at how many technologies are at play here, right? And that it's gonna differ between a job here, and then if you leave and go somewhere else, it's gonna be a wholly different version. So I think there's a lot of merit to this, but why the heck would you do this, right? There's a lot of components there, there's a lot of complexity, that's a lot to maintain. So why would you do it? I think the main reason why you do a monitoring pipeline is to not only tackle these challenges around these paradigm shifts and changes on our infrastructure and our applications, but it's really about the ability to change your mind, right? Even if we look at this one, the constant here is this, right? You're collecting your 6 types of monitoring event data. That's the constant. That doesn't really change. What changes is on the right side here, the data routers and the data backends, right? And you can interchange them. You can try another time series database. You can write to both time series databases. You can even not pay that database for HA and you just double write to 2 instances. You can do interesting things. I think the freedom to change your mind is really the power. You can change your data store. You can change your metric formats. You can change your visualization component, although why would you? Just use Grafana. You can change your sampling method, right? I think now we're starting to talk about tracing, and we trace and we sample at the edge, but what if you say, let's throw all my data into my pipeline, let's sample at the end where it can be more intelligent. These are kind of changes you can make quite easily. You can change platforms. You can add support for other platforms. You can make change inexpensive. I mean this in the amount of time to effort and cost, because really you end up punching above your weight in terms of functionality. You have to like pay big dollars to get anything close to this kind of functionality in a commercial product, even like Splunk, right? They try and build this giant behemoth that does all these things. But you also want to make it future-proof, right? Like as I said, the changes in the way that we deploy infrastructure and manage it, it's just getting accelerated. So we have to be able to take an approach where, I'm going to go all the way back to this, we can have some constants in our life, right? One agent, 5 metric formats, whatever that is, some way of like having a rock to really build our backbone of our nervous system for infrastructure on. Another reason is fewer agents, right? Less edge services to support. Resource utilization is better. You don't have so many sidecars. You like deploy your like tiny web app on Kubernetes and then like 8 sidecar processes. Then you look at your utilization chart, you're like, that's cool. I'm spending like 50% of my compute cluster on sidecars. Cost savings. Yeah, I think it's just, I've kind of touched on how you can save on that. So let's jump into attributes of an effective pipeline. So really, what makes a good pipeline? I would say it needs event payload, either one, kind of a unified payload, or a set of unified payloads. And with unique IDs, we need to be able to source and identify where a particular data came from and its path through the pipeline. Capture context at collection time. So we need the ability to understand when something happens, let's capture as much as we can and represent that within our single payload. That's incredibly important for triaging issues and working through incidents. Support for additional metadata. It needs to be free-form so that any developer can simply start adding labels and tags and annotations, really to enrich the data to make it easier for the operator on the other end or whoever is getting woken up at night. And it's really about supporting efficient debugging, because we've replaced our monolith with microservices so that every outage can be more like a murder mystery. I mean, we do this to ourselves. There's no one else to blame. So here's an example of like our event payload. This is actually what Sensu Go uses. I'll be using a lot of, disclaimer, I'm going to be using a lot of Sensu stuff as examples for these components. That's what I'm most familiar with, and we've designed it in the way that we believe is the best way to do it. So you end up with an event payload. You have metadata, which can be annotations and labels. If you use Kubernetes, it's the exact same thing. Every event has an entity. This is the context around the thing that you're monitoring. This is incredibly important that you build or design a payload to always contain the context of the source. So this will describe a host or an application, a container, and then we'll have a timestamp. There's also a check representation, because check information or check data is really around this state machine, right? Is it up? Is it down? Did it resolve? Is it flapping? So if you're gonna put service checks into a pipeline payload, you need to facilitate that with a very specialized kind of type for that state machine modeling. Metrics. You also need a way that you can represent metrics within your payload and support many dimensions. So, tags and labels are a great way of adding dimensions to your metrics. I think yesterday it was mentioned, like 50% of people were still putting host names in their metric series names. Don't do that. It should just be a tag or a label. Collection agent should be lightweight, multi-platform support. Many of us here use Linux and Windows and Solaris and AIX, I'm so sorry, and a whole smattering of other technologies. It needs to support them all because you need to have this single agent to deploy that consistency across everything. Again, it's all about getting that consistency and that stability and that constant, right? That collection agent and that pipeline established. And you really need bidirectional communication. That earlier pipeline example that I showed was unidirectional, right? The agent just pushes data. Why I say it has to be bidirectional? Well, you need your data plane can still be simple, but your control plane, the brain of the pipeline, needs to be able to orchestrate things. needs to be able to install dependencies on agents, needs to be able to say, hey, you should be monitoring this, right? We don't want just a push world. We want push, but also the ability to pub sub pull objects. You need that bidirectional communication. Auto registration with the backend, right? This is to address the ephemeral issue, right? Things that come up should just simply be found, you should become aware of them, and then they should deregister when it comes time to remove. Should provide platform information, system details, and role and responsibility auto-discovery. This should just be part of the agent. There should be a keep alive heartbeat mechanism so you know when an agent dies, when the host wasn't decommissioned. You need service check execution support. The thing is like, I find over here in Germany and in Europe in general, service checks are still so prevalent and used, I don't really have a hard time justifying this. It's interesting to see like service checks are commonly overlooked and underappreciated in other areas. And it's a great way of leveraging decades of investment. You need to have some sort of durable outbound queue. Telegraph, it was cool yesterday to see the Telegraph queue and the configurable queue length on the outbound stuff. I think that's a good example is like we know things can be unreliable. We need to buffer data when it's unable to write and commit to the database. The agent should have several data inputs. Industry standards, like let's support the standard metric formats so that our developers can push data in using libraries they already have. Same with trace and structured logging. Our data transport needs to support TLS encryption. Like it's 2019. You shouldn't be talking over any network if it's plain text or unencrypted. Should support a standard protocol, something that you can run a load balancer or an application proxy with to like help traverse complex network topologies. As well as the agents should initiate the connection to the backend so that you're not having to punch holes from like the central DMZ into all these separate data centers. Data processor has to be able to scale horizontally. There should be as little coordination with its peers as possible. This is really like distributed computers are a pain in the butt. You want to eliminate these kind of distributed problems whenever you're possible. So by limiting coordination, kind of sharding between the separate independent backends, will get you some ease of use gains. And then it also has to represent or present a good amount of concurrency and parallelism in the backend as well, because as I said earlier, the amount of data that we have to process through this pipeline is ever growing, and we don't want to have to run like 50 machines to compute the data from 50 web applications. It needs to be easy to extend and integrate, and I think this is what I hit on early and kind of ended up landing on this idea of the pipeline, was that it's all about simple APIs and clear specs and providing that framework that makes these things maintainable. Without that, it's just the Wild West, it's crazy, you're not gonna have a fun time, or more importantly, whoever comes after you is definitely not having a good time. Multi-tenancy to enable self-service. We're seeing a lot now where operators and our teams within organizations are providing platforms. We become more of a platform team for our developers. So we provide like monitoring as a service, right? So I need to be able to slice and dice my pipeline in a way that I can be like, you get a pipeline, you get pipeline, you get a pipeline. It's like the Oprah Winfrey of monitoring. Filtering, this is the secret sauce. Any effective pipeline has to be able to have granular routing, right? Does this event data indicate an incident, right? A resolution? Does it contain metric data? Is it production? Is it during office hours? Right? This is like part of that brain. This is part of the control plane. Without it, you just have a dumb pipe. Transformation, you need to be able to transform things. So having that API and that spec to be able to write these extensions that can take that format A and turn it into format B efficiently. This is great because you can just funnel more and more different types of data into your pipeline, and these transformers can take it and process it in a repeatable way and then pass it on to actions. So actions are really the bread and butter part of the pipeline, right? Your alert notifications, your incident management, metric and event storage, inventory, auto remediation, you name it. This is kind of what you're actually doing with that data. So this is an example of a monitoring pipeline, right? And what's interesting is you can have a single event actually hit multiple pipelines kind of confusing because you have a monitoring event pipeline, but within it, there's actually multiple pipelines. What I mean by that is that I can have, say, a service check run, and it says the system is down. I actually want to handle that in a number of different ways. So I pass it to all my pipelines. Is it an incident? Yes, so it goes through here. Do I need to transform the event data? No, it goes to the action. What am I going to do with it? I'm going to send it to PagerDuty. I now have an incident in PagerDuty. Over here, once every 30 minutes, okay, well, it's not the right time, so drop it. We're not going to send it to Slack. Filter, only metrics. Well, it's a check, so it's not going to go this way. Drop it. Only production. It is production. Let's transform it. Let's add some annotations. It's from this data center. This team responded to it. Pass it to the action. What do we do with it? We write it to Elastic, right? We're going to add this to our event store so that we can do reporting on it later. Only logs, not log data. Only incidents, yes. Transform, nothing. Action, it goes into ServiceNow. So that single service check by our filtering logic went to PagerDuty and ServiceNow and Elastic. That's pretty cool, right? And to that point about earlier, making it easy to change, I can simply add and remove as many pipelines as I want here. I can be like, do you know what? Elastic's giving me a hard time. Maybe I really like MongoDB for some reason. I'm going to put my data in there. So going back to this, the issues with this were it was bespoke. It was created by an organization. There's no like defined framework, right? It's unidirectional, so it's going from the left to the right. There's a very strong data plane, very weak control plane. And then if you leave this company, you're going to have to recreate all that from scratch, unless you're able to open source certain components. And then God forbid, people think it's cool, and then they use it, and then congratulations, you're an open source maintainer. So I want to just do some actual demos now of Sensu in action and how I can create some pipelines with it and demonstrate how I believe Sensu itself has a number of attributes that make it effective for pipelining. Also, I don't know where this GIF has been my whole life. So for this demo, I hope you all can read that. Actually, I'll make it a little bit bigger. I totally got to get rid of this prompt because it takes up like a third of my screen. I'm using Kubernetes for this demo, but that's really just a way that I can easily spin up infrastructure on my laptop in a way that kind of looks like regular infrastructure. So what I've done is I've actually created a project. Let me close this one down, actually. So I've created a repo that's open to the public called OSMC demos, and everything I'm doing here up on stage is available in this repo. So you can actually follow along either when the video gets posted or afterwards with all the steps I do, given you have Kubernetes and Docker for Mac or some other means of running Kubernetes locally. So what I'm going to do is I'm just going to first hope this works. Conference Wi-Fi. Error. Sweet. Oh. Never mind that. Pay no attention. Okay, so what have I done there? I've just deployed a HA Sensu backend cluster. That's cool. So I've got a 3-node cluster. They've all stood up and they're communicating with each other. I'm going to go ahead and use the Sensu Cuddle local command line tool to interact with it. I'm going to use the default admin user, default namespace, as that multi-tenancy I talked about, and let's just do an entity list. So this is our inventory, right? Currently we're not monitoring anything. That's cool. What we're going to do now is we're going to monitor a thing. If you're not familiar with Kubernetes, don't worry about it. It's just going to take over your life in the next 10 years. So now what we're going to do is we're going to deploy an app called Web. It's a simple web app. It's got a load balancer in front of it. If I do get pods, we can see that an instance of our application is running on both of them, as well as a Sensu agent sidecar. So one sidecar for all your Sensu, for all your monitoring data. Now if I do the entity list, we can see, oh God, it's so large font is wrapping, but we can see that those sidecars automatically registered with the pipeline. That's cool. Now what's interesting is they've self-identified as a web server, and then they've got their unique generated container pod name with their application name entity. So that's how we can uniquely identify them. So what I want to do is, let's create a pipeline. So I have a number of pipelines here in this repo. One for PagerDuty, one for Slack, one for Influx, and one for Elastic. And really I just chose these because I think they're a fairly good representation of alert, notifications, incident management, time series data, and report generation. So what I'm going to do is I'm going to use Sensu cuddle create-f, pipelines, PagerDuty. And while that's running, I'll show you what that does. So what's really cool about Sensu is that it has these things called assets, which are really tarballs with binaries in it. We use a SHA-512 sum and verify peer to verify their integrity. But here we have a cool filter called Severity Filter. This is a filter plugin. We're going to pull it down. We're going to create a resource for it. And then we're going to create a filter called important. And what we're going to say is we're going to use that Severity Filter asset. We're going to say we want only events that are for warning or critical severity. Then after that, we're going to fetch the event handler to take an action, which is going to be to create a PagerDuty incident. And then we're going to apply that filter, that called important, as well as two built-in filters to that handler. So that what we've created here is, I'll actually touch on this, and then we're going to create a check that uses this pipeline that's going to monitor the health Z endpoint of our web app. So we've got our check over here that's saying, is the application up or down and healthy? Then it goes through, it hits that filter. Is it warning and critical? Basically, we're just filtering out okay and unknowns. And then if it passes through that, it's going to go to PagerDuty. Let's just see. Should be empty. 0 triggered. Cool. So I'm just going to drop out of that real quick. I'm going to post that endpoint because it switches the bool over to be failing. And then we're just going to like pray to the demo gods that it's going to work. One triggered. Sweet. So we just deployed an HA deployment of Sensu, right? We just deployed containers with sidecars that auto-discovered. We just created a whole pipeline with one command, with that one cool little YAML document, that created a check, a filter, and a handler. Pretty rad. Let's do it with something more interesting now. Actually, it's not more interesting. We'll just create it anyways. We're going to do Slack. Actually, I've got secrets in this repo, so I'm going to delete them all. Don't think you can post to this afterwards. So what I'm going to do now, pipelines, Slack. So in here, we're doing a similar thing again. We've got a different filter plugin called Fatigue Filter. This one, what it allows us to do is create a filter that says, only alert me on the first occurrence, and then once every 30-minute reminders, right? Don't spam me with the same message over and over again. This is a great filter to use when you're doing things like email and SMS directly, because God, who needs all that? And then I have a simple handler. There's my secret. You can spam that channel right now if you like. But we're going to use this as a means of notifying a channel. So this PagerDuty is something that's like going through the rotation, actually waking people up. This is very important things. Slack is more like the stream of consciousness or the awareness of the system. Let me just toggle the other one to be unhealthy. And then hopefully it should work. That's pretty sweet. So there we go. We just detected that it's failing. Now what's really neat is I can toggle both those back and hopefully the resolution will come through. But what we just did is we created a different pipeline with a different filter, with a different handler, again with just one command. And hopefully it's going to work here. Maybe. We'll come back. It's eventual. It's hotel Wi-Fi. Cool. All right, next pipeline. This one's interesting. We need some more infrastructure, though. I'll use apply. This one is going to be InfluxDB. So I just created a new pipeline, and this one's really interesting because we've done service check. Seriously, I swear I'm paging somebody. So this one is, I'm just deploying InfluxDB there. I'm going to go ahead actually and just create the pipeline. I'll show you the pipeline. I think that's more interesting. Pipelines, InfluxDB. I also need, oh god, cube CTL, create, -f. I need Grafana because I need to visualize it. While I'm at it, I'm going to just spin up Elastic so that everything's set up. Kubernetes is a hell of a drug. All right. The system. Not bad for conference Wi-Fi. Man, I always give it such crap, but this is pretty sweet. All right, so let's do the next pipeline. I've got 4 minutes. Don't worry, I'll take questions in the hallway afterwards. So what I'm going to do here is I'm going to create the InfluxDB pipeline. And what's interesting about this pipeline is we did service checks already. This is metrics now. So we have a InfluxDB handler. So this takes collected metrics. And really, I'm just using the one built-in filter here called has metrics. So if an event has metrics, it's going to go to this handler. And then I've created a check, which is going to scrape the prom or the Prometheus endpoint on my application. It's going to extract that line format and transform it into one that the handler will understand, or our common one. So actually, if I do, what was it, 8086? Sweet. So that's our GC Go GC duration seconds. So we're now, not only we monitoring the uptime and the service health of the service, we're now also measuring the runtime statistics and application telemetry. If I go over here and reload, it should yell at me. If we go in here, I think I have to like just poke it. Good, it's working. Sweet. I'm having a lot of good luck. Okay, so if we add a query for InfluxDB in the last 5 minutes, fill last. Previous. So now we've got service checks. Now we have telemetry. Sweet. One thing we're missing now, that resolution never did come through, so I guess I messed up my config. It happens. We're going to create another pipeline for Elastic. This one's really cool. Our friends over at NCR, which is a company that's been around for like over 100 years, they're using Sensu Go for some interesting things, and they're now creating plugins that work not only on Linux but also on Windows, and they're also creating some really cool handlers like this one that can take Sensu event data that you've thrown, that unified payload, and write it to Elastic so that you can search it. So I'm just updating the check now so that, what port is that? That's 9200. Sweet. So now we should be able to update this. And we can see that as events come through the pipeline, we're going to store all the incidents into Elastic. Now we can use it for generating our SLA, SLO, and all those reports, outages, and interesting things and facts. So I really hope that made us it works. It's fine. Just 5 minutes late. So yeah, so with Sensu, you can do some cool things. There's other things I want to show, but I don't have any time to keep doing the demo. This is kind of like the web UI so that you can get some visibility into your pipeline and what's going through in this current state kind of thing. Let's go back here. I can wrap up. I got 1 minute or 30 seconds. Future pipelines, I think we're going to see a lot more of the bespoke ones. We're going to see a lot of people putting themselves in the unfortunate situation of maintaining fresh new projects. I think Sensu creates a situation where we can not only make it cheaper and less expensive to change, but also because we use this framework that's common amongst multiple companies, you can take your workflows, your pipelines that you've constructed, forklift from one and drop it into another, which is super exciting. I think we're going to see, God. one last thing. I think we're going to see more people sharing how they build their pipelines. This is how Sensu shares those assets. Like, this is all I did to find one for PagerDuty. I went in here, and then there's a handler for PagerDuty. So we're having more people building pipelines, more people understanding the value of pipelines, and then Sensu's just trying to provide a framework so people can do that consistently and collaboratively. I think pipelines are going to get more observable themselves. We're going to get a better sense of what's going through those pipelines, how they're operating, error rates within the pipes themselves, how we can improve them. Also, I think we're going to see pipelines start to make suggestions. You know, we notice you're monitoring MySQL. 70% of Sensu or other tool users do it like this. I think we're going to see more two-way integrations. Right now, while it's bidirectional internally, it's unidirectional with integrations. I think we're going to see a lot more data coming back from other service providers. So that's it for time. My name is Sean Porter, Porter Tech Online. If you're interested in Sensu, come talk to me or my two colleagues. I've got Anthony Goddard and Cameron Johnston here. And we're happy to talk about it or visit our website. I hope that didn't come across as too vendor pitchy, but I honestly believe that Sensu is quite cool as a technology. And I think monitoring event pipelines are the way forward in terms of how we manage all this data and the challenges that are presented to us. So that's it. Thank you. Any time for questions? Or is it lunchtime?
I hope so. Yeah, it's lunchtime anyway. Domo arigato, Bodoru-san, for your nice talk. Thank you, it was really nice.
Thank you.
Are there any questions right now?
Don't be shy.
Yeah, here, Jan. Pardon me?
You gotta talk into the box, man.
Okay, no problem. Is the TLS encryption you mentioned built in by standard? So you spin up the agent and they use an encryption?
We should.
Okay.
So yeah, like for some reason, TLS is still not easy in 2019 for a lot of people. So it's not secure by default. It is plain text. But we have a number of different guides on like Sensu docs to help people do it the right way from the beginning. Thanks for calling that out. Anyone else want the box?
Yeah, I want to throw it far. Ah, thank you.
I hope you have insurance.
All right, so that was really interesting. I'm curious what's in the sidecar configuration. Does it auto-discover like metric endpoints and logs, or do you have to kind of point them towards all that?
So I think we have the benefit of being a sidecar and local hosts availability. So you can write plugins to discover things, but generally right now the sidecar pattern is quite assumptive. You just assume there's metrics like a Prometheus endpoint, and then a lot of it is push-based APIs. So the application is aware that local host and the Sensu APIs are there. So I think there's definitely a good opportunity to do more discovery within the sidecar pattern. But right now it's just, you kind of have a rigid framework for what Sensu expects and what your application expects. It's a good question.
Good. Anyone else? Well, I guess. Thanks again.
Oh, thank you.
Oh, yeah.
Thank you, everyone.